Hello Calculus student, this video is for chapter 5.5 part 2, U-Substitution for definite integral. So in the first part we say if the integral is very complicated and if it just so happens that we can find a function that looks like composite and then outside there's a g prime that's just the same as which is the derivative of the inside g of x, then we can use U-substitution for g of x and it would work out to be very nice. And so that would be, we did some example on definite integral, indefinite integrals. Now we're moving on to definite integral. So the idea is still U-substitution, but then we want to change the variable of a and b also. We want to change not just g prime of x dx and also f of gx to f of u, but we want to change the ab to g of a and g of b. That means you want to substitute everything in a definite integral. So let's do a few of these examples. A bit bigger. Scroll down over here. So this is example 1. We are doing 0, 1, x, 3x squared minus 4 to the 5th. So this is really big. So if we want to multiply it out, it takes a long time to multiply. So the best way is to look at this as the inside function. And then this inside function, if we just casually look at it, is a square. And if I do a derivative, I would have x dx. And we do have x dx waiting outside. So this is a derivative. It's an integral that can be done by U-substitution. So we say u equals 3x squared minus 4. Then we do the differential du equal to 6x, right, dx. So we have x dx, so we don't have 6. So we just divide both sides by 6. So I have x dx here. So this will be replaced, this will be replaced. And then we need to replace the 1 and 0. So u of 1 is, plug in here, 3 minus 4 equal to negative 1. U of 0 would be, plug in 0 is negative 4 into the u function. It is actually the g of x, but I just use u. So that is 0 minus 4 is negative 4. So the whole integral now become not 0 to 1, but negative 4 to negative 1. And then x dx become 1/6 of du, and then this 3x squared minus 4 to the 5th become 3x squared, become u to the 5th. U to the 5th, and then du over 6. So we move the 1/6 outside, and then you do u6 over 6, and we have to evaluate from negative 4 to negative 1. So that means we start from plugging in negative 1, so 1 over 36, negative 1 to the 6, minus negative 4 to the 6. So that is 4,095, or negative, over 36. And if you simplify it, I think they're divisible by 9 is negative 455 over 4. So that's how you do change of variable. The book call it change of variable, but primarily it's still U-substitution. So another one, do a definite integral from 0 to 2 of 4x squared square root of 3x cubed plus 6. This is actually a plus 6. I didn't change it. But in your notes that I uploaded, it should be a plus 6. I changed the original one, but I didn't change this one. So this is a plus, and also this is a plus. So let's look at how to do it. Oh gosh, how come this? Yeah, let's do it again. So this, and then, oops. Okay, so it is a plus, and I think this is a plus also. I changed the notes. Obviously, if I make this as u, I would have 4x squared dx, or can have x squared dx waiting outside. So that's a good idea. This would not be my U-substitution, but things that is inside function. So I'll write u equal to x cubed plus 6. And then du would be, you see how you have x squared that shows up? But I want 4x squared. You have 3x squared. So what do? You multiply by 4 over 3, right? 4 over 3 du would, if you multiply by 4 over 3, it becomes 4x squared dx. So just make it so whatever that you have, you can replace it. But because we are doing a definite integral, we have to do u of 2 also. That would be 2 cubed plus 6, 8 plus 6, 14. But what about u of 0? That is equal to 6. So this definite integral now becomes 6 to 14. This is 4 over 3 du. And then I have u to the negative 1/2 because that's 1 over square root of u, and then du. So everything is can be done by power rule. So it'll be 4 over 3 u to the 1/2, right? Negative 1/2 plus 1 is equal to 1/2. So divided by 2 divided by 1/2, that means times 2 over 1 u to the 1/2. And then we plug in 14 to 6. So then it will be 8 over 3 outside. It will be root 14 minus root 6. And that's the final answer. Okay. Second one is they're not very nice number. So second one is this one, x squared plus 1. And it's a cube root. And we have x waiting outside. So if you use u to represent this, that will be x squared plus 1. So du is equal to 2x dx. I have x dx. I don't have 2, so I just do 1/2 du x dx. Okay, so that's so good. Oh, but I need to replace this also. U of 2 would be 5. U of 0 would be what? 1. So this new, the integral, the definite integral now become not 0 to, but 1 to 5. And then my x dx would be half du. My x squared plus 1 to the cube is u to the 1/3. And then times du 1/2 outside, right? So it will be 1/2. 1/3 plus 1 is 4 over 3, so it's times 3 over 4 times u to the 4 over 3, 1 and 5, right? So that means 3 over 8, 5 to the 4 over 3 minus 1. Is it 4 over 3? Is it 1/2? Right, this is a 1/3. Right, so plus 1, 1/3 plus 1 equal to 4 over 3. And then our multiple will be 3 over 4. Yeah, so that's it. That's the answer. The last one is from 0 to 1 x squared cosine pi x cubed dx. So there's some x squared outside and then some cosine. It is not a product rule. But you can see that this is inside cosine, so there's a reason to believe that you can just do u like that, because when you do du, it will be 3 pi x squared dx. You see x squared dx is here, so you multiply by 1/3 of 1 over 3 pi of du. That would be x squared dx. That means you just divide this over. And then we have to do u of 1. U of 1 is 1 times pi. U of 0, that means 0. Okay. So the integral now become 0 to pi. X squared dx become 1/3 pi. So move the 1/3 pi outside. And then du to cosine is just cosine u du. Right? Cosine u du. So it is 1/3 of a pi. What is the cosine? It's sine u from 0 to pi. But 1 over 3 pi, sine pi, minus sine 0, they're all 0. So the result is 0.